In this video, we are going to graph quadratic functions when they're in vertex form. So here's what we need to know is that vertex form looks like this, okay? And then the A value, this is going to be our vertical stretch. Or it could be our vertical compression. And if it's negative, that's going to cause a vertical reflection. So we're going to kind of look at that in a minute. But that A value controls those things about our parabola that we're graphing. And then this number right here, that H value, is going to be our horizontal shift. It's going to shift our parabola left and right. And then this K value right here is going to be our vertical shift. So we're going to look at every quadratic that's in this form. We're going to look at it as a transformation to the quadratic parent function. So let's start with this example. And so what I'm going to start by doing is, if I called f of x this function, let's start by graphing g of x as x squared, and that's our parent function. And I'm not going to talk a whole lot about why the parent function looks like this, because I do that in other videos, but let's say I've got my quadratic parent function, kind of my parabola that looks like this. So what we have here is we don't have an A value. Our A value over here is a 1. That means that there's no stretch, there's no compression, and there's no reflection. So all we're doing is we're doing a little bit of a horizontal shift and a little bit of a vertical shift. Now here's where you got to be careful. Even though that comes after a minus, you might think, oh, a minus 3 means you're moving to the left 3. The shift is what comes after the minus sign in this case. So if this is x minus 3, we're actually going to shift to the right 3 units. And if this, where it's extra confusing is this minus 2 isn't backwards from what you think. It actually does mean we're going to shift down 2. In this video, I'm not going to go so much into the why that's the case, but let's just kind of follow these steps. So we're going to take our quadratic parent function, which you've shown in black. I'm going to shift it to the right 3 units, and then I'm going to shift it down 2 units. So I'll do my new function in blue. But if I take my vertex and I go to the right 3 and then I go down 2, it should put my new vertex right there. But then all the other points will have the same relative position. So just as far as a rough sketch, every point from this original parent function should have shifted to the right 3 and down 2. This point should have gone to the right 3 and down 2, assuming I drew it well. But that's all that's going on with this example. Let's do an example that's slightly more complicated. So right here, we have this quadratic. Now this quadratic's in standard form. So for us to graph it, let's first convert it to vertex form. And our way that we're doing that is we're going to complete the square here. So if I write f of x equals x squared minus 6x plus 7, what we do here to complete the square is I'm going to put a set of parentheses with that plus 7 being outside the parentheses. And I'm going to add some number here to complete the square. So if you remember how to complete the square, I'm going to take this middle term, I'm going to divide it by 2 to get negative 3, and then I'm going to square negative 3 to get a 9. But if I add 9, I have to also subtract 9 so I don't change the value of my function. And so now we're basically here. I'm going to recopy what we have. We have f of x equals x squared minus 6x plus 9 plus, minus 2, because this value right here, when we simplify, becomes a negative 2. Now, the reason we completed the square is since that's a perfect square, I can rewrite it in factored form. The factored form of that is going to be x minus 3 squared, and then I copy down my minus 2. So we have this right here. Now, we have now successfully, by using this process called completing the square, I've taken a standard form quadratic and I've rewritten it in vertex form, which this makes it a little easier to graph. And hopefully you're saying, lo and behold, this is the same quadratic we just graphed. And it is. We're going to take our parent function, we're going to shift it to the right 3 units and down 2 units. So although you already know what it looks like, to the right 3, down 2, and then we've got the rest of our points in their corresponding positions. But the moral of the story here is that if you want to graph a quadratic, there's ways to graph it out of standard form, don't get me wrong, but if you want to, you could just complete the square to convert it into vertex form, and then you can just identify how this quadratic is a shift or a stretch from the quadratic parent function.